of an ammeter, and how can an ammeter be calibrated through the process of electrolysis? A very nice question indeed. Now look at the diagram on the board. Very clear. A very close look, you will see that there are two copper electrodes. One serving as anode, copper anode. The other one is serving as copper cathode. These are two copper electrodes. So why do we then have two copper electrodes? Because we want to check something. We want to check, we want to observe what happens after current has been allowed to pass through the system. What happens to the electrodes? And that will give us some kind of hints of the amount of current that we need to take note of when carrying out an experiment like this. So let's see. Then the first thing is this. The experiment is set up the way it is on the board. In the lab, this is the way you are expected, a student, a teacher, whoever is concerned is expected to set up the experiment. Okay? If this is done and done properly, then what happens next is we begin to take it one at a time. One at a time. But before we delve into explaining all this, there is something I would want you to do for me quickly. Subscribe. If you are finding value in this, please subscribe. Give me some thumbs up. Encourage me. Nothing else. Share with your students. Share with your friends and networks. Okay? Put on the bell button for constant notification. That's all. That's all I'm asking. Make it go viral. Simple. Alright, enough of all that. So let's see. Copper cathode. This is cathode. Alright? Look at this. Copper cathode. Copper cathode. Okay? What happens is that the copper cathode is weighed before current is allowed to flow into the system. Copper cathode, as one of the electrodes, is weighed and a certain amount of mass is obtained. That's the original mass of the copper cathode. Take note. Then that value is noted somewhere and then fixed back again. I'm talking about the cathode, not the anode. And then fixed back again. Then the question is, why are we concentrating on the cathode instead of the anode? Simply because we are talking about copper sulfate solution. So whatever ionic process that will take place here, the positive ions will always drift towards the copper cathode, because copper cathode is negatively charged. So you want to see, and because they drift towards this, they will always deposit on the copper cathode electrode. If we have understood that, now what happens next is this: we fix it back again. Remember, first of all, to weigh it. After weighing it, take it back again and fix it into the arrangement once again. Once that is done, current is turned on. Once current is turned on, the rheostat is adjusted appropriately to a current value of 1.5 amps. For 30 minutes, when the rheostat is adjusted to allow current value of 1.5 amps to flow through the system for 30 minutes, as you can see, we maintain it. We continue to maintain that for 30 minutes. The current I is maintained steady for these 30 minutes. Each time the rheostat is adjusted, 30 minutes is allowed to pass by before another adjustment is taking place. We continue that way until the process is over. Once the process is completed or is complete, what happens next is to bring out the cathode once again, the second time. Take it the second time. Wash it thoroughly. Wash it thoroughly. After washing it thoroughly, get it dried. After drying it, reweigh it again. We put it again and reweigh it to know the new mass of the copper. To get the mass of the copper deposited. So once that is done, we now know the value of the mass of the copper deposited. We already know the amount of current flowing into the system as 1.5 amps. Then, of course, for 30 minutes, that's time. T, for 30 minutes, is taken care of. Look at it there. For 30 minutes. If we don't know the value of all that, it means the mass of copper deposited in the process is directly proportional to the current and the time taken for such amount of mass to be deposited in the first place. With that, we have this. But there is a problem here. We have direct proportional sign. What do? There is a constant, a proportionality constant called electrochemical equivalence of the whole process. So we take into consideration electrochemical equivalence of the system during this electrolysis. All right? So what happens is that by the time we change the proportionality sign to equal to sign, we introduce a constant Z. I is there and T is there. We can now find other things. But mass is known already. If we know the value of mass after washing it, drying the copper and weighing it once again, we have the value of mass deposited. We now know the value of proportionality constant, the electrochemical equivalence, and then know the time, 30 minutes. We can as well find current flowing. We can as well find current flowing different from this. And that is how we can use, or the process we can apply in calibrating an ammeter. It's very simple. It's very, very simple. If any of my explanations is not clear, put it in the comment section and I will address that in my next video. Give me some thumbs up, encourage me, come on. Subscribe if you have not. Alright? Share with your friends, networks and students. Don't forget to push on the bell button for constant notification so that each time I upload content like this, you'll be quickly notified. I am signing out once again to prepare for the next class, which will be linked up there or somewhere there. Okay, see you in my next class.